Approximately 97.5% of Earth's water is in the oceans, making it saline. Only about 2.5% of Earth's water is freshwater, found in glaciers and ice caps, which make up 68.7% of that fresh water. Groundwater accounts for 30.1%, and surface water, like rivers and lakes, makes up just 1.2%. Hydrology and hydrogeology. Hydrology is the study of the movement, distribution, and quality of water on Earth. It includes the hydrologic cycle, which encompasses precipitation, evaporation, infiltration, runoff, and groundwater flow. Hydrogeology, on the other hand, is a subdiscipline of hydrology focused on the distribution and movement of groundwater in the soil and rocks of the Earth's crust, which we call aquifers. Major basins and groundwater provinces of India. Let's start with the major river basins. The Ganges Basin, the Indus Basin, the Brahmaputra Basin, the Godavari Basin, the Krishna Basin, the Mahanadi Basin, the Cauvery Basin, the Narmada Basin, and the Tapi Basin. Now, moving on to the groundwater provinces, there's the Indus Basin in northwest India, the Ganga-Brahmaputra Basin in northeast India, the Peninsula Plateau, which covers central and southern India, and the coastal plains along the eastern and western coastal regions. Darcy's law and its validity. Darcy's law describes the flow of groundwater through porous media, stating that the discharge rate is proportional to the hydraulic gradient and the permeability of the medium. The discharge rate, denoted as Q, is equal to the product of the permeability, represented as K, the cross-sectional area, denoted as A, and the hydraulic gradient, represented as I. In words, Q equals K times A times I. Now, regarding its validity, Darcy's law is valid for laminar flow conditions in homogeneous and isotropic porous media. However, it may not be applicable for very high or very low flow velocities or in fractured or highly heterogeneous media. Groundwater levels fluctuate due to various factors. First, we have seasonal variations. These are changes in precipitation and evapotranspiration rates throughout the year. Then there's extraction and recharge. Human activities such as pumping and irrigation can cause significant fluctuations. Lastly, climate change. Long-term changes in climate patterns affect groundwater recharge and levels. Hydraulic conductivity, often denoted as K, measures a material's capacity to transmit water. It depends on the permeability of the medium and the viscosity of the fluid. Groundwater traces are substances used to track the movement of groundwater. These include natural traces, such as isotopes like tritium and carbon-14, and ions like chloride and bromide. Then we have artificial traces, which can be dyes, salts, or other chemicals introduced into the groundwater system. Land subsidence is the gradual sinking or sudden collapse of the ground surface due to the removal of subsurface material, often caused by excessive groundwater extraction. The excessive use of groundwater can lead to several serious consequences. First, there's the depletion of aquifers, which means reduced groundwater availability. Then we have land subsidence, which can cause structural damage to buildings and infrastructure. Not to mention there's reduced water quality as the concentration of pollutants increases. And finally, the ecological impact, which includes negative effects on wetlands, rivers, and lakes. Groundwater quality is influenced by natural processes and human activities. Key factors include chemical composition, which involves the presence of minerals, salts, and pollutants. Biological contaminants like bacteria, viruses, and other pathogens also play a role. Additionally, physical properties such as turbidity, temperature, and color are important considerations. Pollution of groundwater resources can result from several sources. Agricultural activities contribute through the use of pesticides and fertilizers. Industrial discharges release chemicals and heavy metals into the environment. Urban runoff includes oils, solvents, and other contaminants. Lastly, improper waste disposal, such as leaching from landfills and septic systems, further exacerbates the problem. The Ghyben-Herzberg principle explains the equilibrium between freshwater and saline water in coastal aquifers. This principle states that the depth of the freshwater-saltwater interface below sea level is approximately 40 times the height of the freshwater table above sea level. In summary, understanding the distribution and movement of water on Earth, especially groundwater, is critical for managing water resources, preventing pollution, and mitigating the effects of excessive groundwater use.